Welcome to episode 3, and we're still on the shader foundation. Oh well, not to worry, let's get this program underway. We have a file name and we have a constructor for shader foundation, so let's get it done. And we are going to start with mprogram, and we've called it mprogram ID, so that's what we're going to call it. And that's going to equal GL create program. We have to register our program, so let's do that. There it is. Does that need anything? Nope. It just creates a space on our graphics card for our program. There you go. That's all it does. Doesn't do anything else. And now we have the shaders. So let's create a couple of shaders, shall we? As you have realized by now, there are two parts to each shader that we are going to use. There's plenty more in there. You can do quite a few different types of shaders. I can't remember at the last count how many there were, but I think I encountered about 10. Yeah. But the main two are going to be the vertex shader and the fragment shader. So we shall do those. The first one we're going to do is the vertex shader, so that's m_shaders. And this is going to be 0, the first one, because we've allowed 2 of them, remember, from the header file. Let's just check, make sure we have set 2. Yeah, number of shaders 2. M shaders, num shaders. There we go, that's lovely. So the first one is this 0. And it's going to be create shader. Hey, guess who wrote that? We did. So what does it need? It needs a string of text and a shader type. So the string of text is going to be... oh, grief. It's going to be... I don't like this. What have we done? What have we done? Let's have a look and see what I've done first. Create shader. String and text. Text source. Yeah. Whoa. Oh, stupid me. Yeah. Do apologise. You can't create the shader without loading the shader, can you? So that string of text is actually the return value of load shader there, which is returned as output. So we can use that here. So where we're going to be passing into create shader a string of text, that string of text is the shader itself. That GLSL stuff. Oh yeah, I can do that. Yeah, we can do that. So let's get my head around that. Yeah, so it'd be load shader, which we should have here. Yep. That needs a file path. That's all it needs. So let's give it a file path, which is yeah, src /API / what do we call it? GLSL? GLSL / plus file name plus .vs for vertex shader. That's that bit correct. I'm not happy about this at this stage. This may change. I'll look at it at the end of the recording, but I'll look at it off air, because we have a slight problem here, which I can explain quite easily. This is going to be a static library, and the GLSL files should be in test. They're actually not part of the static library. I've only included them in the static library so that I can show you what they're going to be. They shouldn't be here. They aren't part of anything. GLSL really isn't part of anything except for OpenGL. What else do we need? We needed a type of shader, didn't we? So we need a comma and GL vertex shader for that, I think. GL underscore vertex. It'll be underscore again, I guess. Shader? Yeah, it is. Oh, fantastic. Yeah. Sorry to sound surprised. Let me just take that off. There you go, you can see it all now. I'm just going to break that line down a little bit. Best way of doing it. I'll do it at the comma like I normally do. A little bit too far. There we go. That's okay now. Yeah, that's better. We can see it now properly. Excellent. So that will load and compile a shader all in one line. Yes. So mshaders now contains a compiled shader. And it should have given us a return value of a gluint. That's right. So we have our return. That's gone in there. That's beautiful. Beautiful. That's worked out nicely. And all we need to do is exactly the same. Repeat that line. Copy. And paste. And we just need to change that to number 1. And that to a fragment shader. And that to fragment. There we go. That's that done. Yep, I'm happy with that. So we have now compiled both of our shaders. Yes, it was that easy to compile. And they are both error checked fully whilst being compiled, and it's all done by those two load shader and create shader functions down below in the private section. They do all the work, and all we need to do now is attach the shaders. We've compiled them. We now have to link them. That's how C works, and C++ works in the same way. You compile them into object files, and then you link them into the final file that can be run. Final file, yes. the executable file. That's the correct term for it. So, the first things we have to do here. Have I used unsigned ints again? Doesn't matter. Does it matter? What have I used here? It doesn't matter. I'm going to use gluints. So GL. I'm going to stay with OpenGL because it is an OpenGL piece. So it's gluint I equals index for I 0. We'll do the full one. So it's I is less than the number of shaders, which in our case is 2. You may want to put more shaders in. I don't know. You're writing your version of this, so if you want to put the what is it? Strange shader of doing strange stuff. You want to add it into here? You can. This makes it easy to add stuff at any time you want. So increment I, and it's for loop. Don't really need the brackets. I'm not even going to bother because all we're going to do is GL attach shader. It's the second one down. Open brackets. What does it want? it wants the Gluint program, comma, Gluint shader. Well, the Gluint program is mprogram, or mprogram ID, so that's that one. And it wants the shader, which is m_shaders, and it's just going to be I. That's right, it'll go 0 and 1 for that. Yep. Happy, happy, happy. There we go. Yeah, we need to attach both shaders. This is where OpenGL goes a bit strange and decides to take a left turn at Barnard's star. Because we need to, at this point, discover what the layout is. Remember, we're talking about the layout, and layout 0, 1, 2 being the different variables. Well, we need to know where it's placed those variables, and we can't do that if it's linked. Once it's an executable, we can't access it. At this stage we can, because it's still within coding. It's in object files. Object files are assembly, are they? I think they are in assembly language. Don't quote me on that. I don't exactly know how OpenGL is doing this bit, but we are going to interrupt the process just for a second to bind our attributes. And we should have bind attributes. Where is it? Hold on a minute. Bind. There it is. Attributes. ATTRIB. Yeah, I think I spelt it right. So we're going to interrupt the process just to do that. Okay, we have to do it at this point. If we don't, we miss out. We miss the boat, basically, and it has to be done in between the create shader and the final linking of the program together. So we can now link the program together, and it's link, GL link, and it's GL link program, please. And all we do is put in m_program ID. There we go. It's very nice, isn't it? It's nice and easy. I mean, there's nothing special about that. But we now have to do double checks now to make sure that the linking has worked correctly. This is critical. This checking of the shader program is, I mean, the actual generation of the shader program is out of our hands. It's up to OpenGL. And that OpenGL has had the manufacturer's software engineers involved, and we are relying on their programming to be correct and their software engineering to be correct. And if they are Microsoft engineers, I usually stop and think. So we are going to check everything, absolutely everything. We are going to check it. We're going to then ask OpenGL to check it. And then we are going to check OpenGL's check. We're double checking. Yeah. So let's check, shall we? Check shader error. Awful. I know I am going to the extreme on this, but it's so extremely important. To be honest with you, nothing will work. If this doesn't work, the whole program, everything goes down. This has to be spot on, you know, absolutely dead on. So we are going to check the shader using the program ID again. And this time our flag is going to be the GL link status flag. There we go, that's there. It's a program, so it's true. So we're checking the program status, and let's give it an error. What should we call it? I don't know. Error. Yeah, that's a good idea. Let's call it error. Very original. And this is going to be for the GL link program. Failed. And of course it'll give us an error message as well, because we're sending it through so that it will give us an error message. Pop that in, semicolon. Then we are going to ask OpenGL to do the same. And to do that, all we do is put in GL validate program. It's the top one. And again, that's just program ID. Top one. Oh, nice. Working out nicely today. And then again, we're going to check that. We're going to check the validation. Because it's not going to tell us. If we put in GL validate program, program ID, there's no return value. There's no return from OpenGL. We have to go and get it. And that's why we wrote a check shader error program. To be honest with you. So check shader error, and it's program again, isn't it? So it's program ID. This time the flag is GL validate status. Yeah, that's why we had that flag, so we could do each part. It's true again, isn't it? Yeah, of course it is. It's the program that we're doing. Go on to the next line, put the error. So we will put error. And this time it will be GL validate program. Failed. You can see I'm doing a very simple set of errors, but it tells us exactly where in the program things are failing, in case it does, which it shouldn't. There's no reason for it to do so. And once we're at that stage, we've checked everything, we've double checked everything, we've turned left at Barnard star and bound the attributes. We have finally got a shader program. And that shader program is stored in m_program ID, which we can get the program ID at any time from outside of this using getProgramID. So our shader program has boiled down to that line. There's no return value needed because we have this function. Cute. Very, very nicely done. So all of this messing about has just become that. There you go. What happens when we close down? Then we need to actually close down properly, don't we? And we do have to close down properly because, again, the shader is not in our memory. It's on the graphics card. C++ does not delete your graphics card memory. It won't touch it unless we tell it to. So at this point, we want to stop all shaders from working. Any shader that's running, please stop. And then for, we're doing that same for loop, aren't we? Yeah. GL uint I equals 0, semicolon to I is less than num shaders. It's just the same as before, shaders, semicolon, and then I++, I increment. And each time we go through this, we want to do two things. We want to detach the shader from our program. Yes, we're going to have to detach it. This is quite intricate stuff, this, and OpenGL does explain this in the OpenGL manual, but it's, yeah, right, okay. You have to do what? Yeah, I know. It's just one of those things. We have to detach it, and that comes under M shaders, and that's I. There we go. And then we can delete it. So it's GL delete shader. Yeah, there it is. And that's just m_shader I. There we are. All done. Nice and clean. Nice and simply put, but we have to do that double bit. And then once we've deleted the shaders, yes, we have to then do a GL delete program, because we have then got the ability to do so. There we go, and that just should be mProgramID. There we go, well done. GL delete program ID, wow. So we stop any shaders from running, or stop the shader from running if it is doing so. We then detach the shaders individually, both, there's two of them, and then we delete both of those shaders, because there's two of them, and then we can delete the program because everything's been deleted. Nice. Start and stop. How do we start and stop a shader? Let's get on with this. So to start a shader, do I have any coffee left? Oh gosh, I do. There is a GL command for it, and it's use program. There we go. So use the shader program, and it's just m_program ID. There we go. That's that done. A nice big function. To stop using a shader, you can laugh at this because it's still GL use program, ironically. I think you can guess what we're going to put in there. A 0. 0 defaults to stop. So that's those two done. That was nice and easy. What else we got left here? We've got, oh right, putting things into the uniforms. Right, let's just skip that for a second. Bind attributes. We don't do this part. That depends on the shader, which shader it is. So this is override this to set the attribute list. Full stop. Okay, that's alright. Once we're here, we can do bind attribute, I suppose. May as well get these two out of the way with next. Bind attribute is literally GL. Nothing strange coming up here, bind. And I bet you think it's going to be attribute or location, the second one down. So it's bind attribute location, and it's mprogram ID, and then what do we need? The index, which is the attribute number, or attribute that we've called it. Attribute, like that. Yeah. What next we need? And it's just the variable name, isn't it? Yeah. Const GL char star name. Const char star name. Yeah, that's fine. I should really use GL there, shouldn't I? Yeah, I should. Sorry about that, I'm going to change it. Told you things were not set in stone with this one because things just... That's a GL. Which means that that is a GL as well, back in the header. Did warn you about this. So in the header, please correct const GL char star variable name, and in here const GL char star variable. That's what it asks for. That's what we're going to give it. We gave it a GLU int attribute after all, so why not? It makes it platform independent, and it means converting this to other platforms will become easier. It is already platform independent, the whole code, I've tested it, so don't worry. So that's that one done. Anything else we can do around here? No, not really. Let's do these now. I think that this, yeah, we're on to the last bits now, aren't we? There's only these bits to do, so I suppose we'll have to do them. Let's see how we can load a uniform, shall we? And it's GL uniform. And then we've got to get the type. So it's it's a float, so it's going to be 1F. That one, please. There's different types. That's why we need all of these different ones, because each one of these is a different type as we go along. I'm going to explain why, actually, because normally I don't see people explaining why. It's location given and value given. Glint and a GL float. I'm going to change those as well. So that's value semicolon. No, I'm not. It doesn't matter. No, for completeness I am. Stuff it. Let's explain it all. It's a GL float. So that's this one. I've got a feeling that all the rest are the same, so we may as well do all the rest whilst we're here. No, we won't. All the GL ints are. I'm not happy with that vector one yet. We might have to stop at that point. Oh no, I am happy with the answer. I don't know if there is a GL bool, so I won't do that one. I'll leave the rest of them, so we can save those out, which should give us no squigglies whatsoever because they're exactly the same thing on my machine. Might give you squigglies, but it won't give me any. So I'll GL all those. Now, you're thinking to yourself, hold on a minute, what's this GL uniform business? What this does is it sends the value that we give it through to that uniform location. And you will see in the main shader how we get the uniform location, and then we use that uniform location to send or load the float through. This is just makes these are what I call lazy functions. All of shaders are going to use them. You may as well put it here. It's as simple as that. These can actually go into the shader if you wanted them to, but it's better to put it here. So it's because then it saves a lot of typing. It's uniform. Whoops. What do we need now? We need a vector. So for a vector, we will need 3 floats. Yeah. This is why I wasn't bothered about it being an ampersand sign, because there isn't actually a load. There isn't a uniform vector. There isn't one. Simple as. So you can tell what's going to go here. It's location, and it tells you what it's after. It's after a GL float, and that GL float we get from vector. Here we go. Vector dot x comma vector dot y comma vector dot z. All we're doing is we're following my handy hints thing here, and that's all I'm doing. Dot z, converting it into what they actually are. So there we go. So we're passing the address in because it doesn't matter. That's perfectly alright. So that's 3 floats equals our vector xyz, and that goes into location, whatever. We don't know. We actually never know the location. We're just going to get the location from OpenGL and then pass it into these functions to load up the values. You'll see that in the actual shaders themselves, and Muppets decided to do something stranger. GL uniform. Get out of the way, Muppets. Settle down. Location. Oh, whoa. Which one are we doing? Which one are we doing? Boolean. Oh, right. Well, what's a Boolean? Hold on a minute. Cat's on my microphone. It's a 1F. We actually have to use a float. Do we? Well, it's a bool value coming in. So what do we actually have that can cope with a bool value? A bool value can be true or false. I'm going to use 1F. I don't really mind what we use. Doesn't really matter. And it's location, comma, result, because we don't know what it is. We have to convert it. We're going to have to convert it from a bool to a float. Which doesn't make sense to me. 1D, 1D, oh, 1I. How are we storing it? How does GL use it? I'm uncertain how it's going to react. So let's put a float in. Result equals 0. There we go. And if value is true, then result equals 1. So false is 0, true is 1. There we go. That's all we have to put in, and that will then pass into there as a float, the result. Not overly keen on that. I'm very tempted to put a to-do in there. Should this be an integer? Not sure, but if we leave it like that. We're not actually using bool in our logic within our GLSL, so there's no way of testing it at this stage. I will test it when I get round to doing my colours bit. Coloured objects and entities rather than just textured. So, and that's something for me to look at later, I think. This one is, oh gosh, what are we doing first of all? Matrix, oh lovely. GL uniform, and this is going to be matrix. Which matrix do we want? 4? Well, 4 by 4. That's integer. Is there just a 4? Hold on a minute, matrix. Can I yeah, I can just put the number 4 in, can't I? 4 float values, yeah, that's it. I think that's going to be the best one to use. Now, when I did the matrices in our maths area, we have to look at it. We have to look at it now because of this transpose, GL Boolean transpose things. OpenGL uses matrices that are in column major order, which means it goes down each column, then to the top of the next column, and down the column, top of the next column, down the column, and that's how it stores them. Well, we haven't. If you have a look at our matrices, we went float across the row, float across the row, float across the row. Well, OpenGL goes float down the column, float down the column, float down the column. Yeah, we've got our matrix 4 the wrong way round. But it doesn't matter. It doesn't matter. Because we can get out of that quite happily. Let's just open these brackets again so I get my thing back up. So, location is location. Then we need the count. We want 1 matrix, please. Thank you. And do we want to transpose it? Yes, we do. We want to transpose it. Normally, you'll see everybody saying, no, we don't, leave me data alone, put it GL false. You've always put it GL false. Actually, no, you don't. Only if you're using column major maths. Here you go. So you've learned something there. Now, I brought this in as a mat4 matrix. So now we have to do the address of matrix. And we are going to have to dot that with R0C0 to get the address properly. I don't need another bracket, do I? No. Okay, lovely. Yeah, it's a weirdosity. It's asking for something weird there, a weird address of an address. It's a pointer to an address. And that's what that gives, is that format of C++ will give us a pointer to the address of the very first object in the matrix, which is R0C0. Lovely! Are we done now? Override. Yeah, we're done. Oh my god. It looks good. We're at 35 minutes. I think we've done good. I'm going to go and think about my booleans. Why not? Everything else is correct. Using the program's correct. Deleting deletes the correct order. Yeah. You've got to do those in the correct order, by the way. And this is all in the correct order. Bind attributes is in between the creation and the linking. That's got to be done. I can't show you bind attributes because it's an override. It depends on the actual shader itself. And we will be next going on to shader, well, from shader foundation we'll be going on to the static shader, or shader static, as it were. And then we'll be doing, obviously, shader terrain as well. We have that shader to write. So we've got 2 more shaders to write, and then I'll be happy. But that's the foundation. Both the next 2 shaders will be using this foundation, and I'll show you how to do that in a special way using C++ and some rather nice techniques that C++ allow us to do. Makes everything so much easier because we've done all the hard work. That was it. Yeah. That's your foundation done there, your foundation done there. All we need now to do is add them. Never forget to add them. So we have source / OpenGL. Yep, open. Got to make sure I get the right capitals here. OpenGL. And then we've called it shader foundation. And that's .cpp. .cpp. We need to add the header file, which is source OpenGL, and then it's just shader foundation .h. There we go. Check, 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 check. Source OpenGL. Lovely. Yeah, that's added now. Terminal, run build, and wait, and it's been added. So there's no coding errors in what I've shown you. The code is legal and legit, which means it's okay to run. Excellent, that's great stuff. I was expecting an error there because I usually make typing mistakes. If I have made any mistakes, I will correct them in the next video, as usual, I hope. I'll be seeing you in the next video, where we will be going on to the static shader, which I'm going to call shader static, just to be awkward. Shall I? Shall I not? No, I'll call it static shader, I think, so it makes more sense that way around. Okay. All done? You people, take care, and above all, have fun.